This video is going to show several concepts that, when put together, can help create the ideal gas law, which is really the overriding equation for this entire chapter. And I'm going to show a couple different versions of the ideal gas law, so that depending on what values you're given in the problem, you have a couple different ways that you can set it up. So first, there are a couple smaller gas laws that were developed. First is Boyle's law. Now, Boyle's law basically states that the pressure times the volume in a gas is equal to a constant. So what does that mean? Well, when two things are multiplied by each other and are equal to a constant, what is their relationship? To show that, let me use an example. Let's say we have 4 times 2. That equals 8. Well, if I increase 4, so now I make that 8. In order to keep them equal to a constant, 2 has to decrease. So if two things are multiplied by each other and equal to a constant, they have an inverse relationship. If one increases, the other has to decrease. And in fact, they have to increase and decrease by the same factor. This one increased by a factor of 2, so this one had to decrease by a factor of 2. So this shows an inverse relationship between pressure and volume. Another is Avogadro's law. And if you recall, Avogadro's number was when converting between, was basically the amount of particles that exist in a mole, and you could use that to convert between the number of moles and the number of particles in a sample. And likewise, number of moles comes back into play here. So what this says is that V over N equals a constant. So now if you have two things divided by each other equal to a constant, what does that say about their relationship? Let's do another easy mathematical example. So let's say we have 4 divided by 2. That's equal to 2. If I increase 4 to 8, well, I have to keep it equal to 2 because it's a constant, right? So now I have to increase 2 to 4. So this kind of a relationship shows that there's a direct relationship between volume and the number of moles. If one goes up, the other also has to go up. And the last, smaller gas law is going to be Charles' law. And Charles' law states that the volume divided by the temperature is equal to a constant. So just as with Avogadro's law, this is showing a direct relationship, but this time between volume and temperature. And when you put all three of these together, you get P times V equals N R T. And this right here is the ideal gas law. Again, that is the overriding equation that will govern the vast majority of what you'll do in this chapter. Now let's break it down a little bit. So P, as I've mentioned, is the pressure, and the unit it has to be in is atmospheres. V is the volume, and the unit that has to be in is liters. N, of course, is the number of moles. I'll get to R in a second. And T is the temperature, and that has to be in Kelvin. So now R. R is a gas constant. Its value is 0.08206, and its units are liters times atmospheres divided by mole times Kelvin. That entire thing is the unit for R. And the way you can remember it is that it's just the numerator are the units of the two things on the opposite side of the equal sign, and the denominator are the same as the units as of the two things on the same side of the equal sign as it. So it is a constant. It's always going to be that number. Okay? So that is the primary version of the ideal gas law. Basically, if you're given some of these values and you're given just one set of conditions, something that says the pressure is this, the volume of this, and the temperature is this, how many moles of gas do you have? This is what you're going to use.